Hello, my name is Evelyn Bravo, and this is my presentation on Lab 1, Constant Velocity for Physics 1. The purpose of this lab was to observe the relationship between position, time, and velocity. This ties into Newton's laws, which state that an object will remain in constant motion or rest unless a force is introduced that will alter its speed, position, or direction. We're going to be doing an experiment that I will explain in just one moment, where we will be testing these three components, and the data collected through observing this experiment can then be used to computationally predict an object's future position and activity with a constant velocity. So related fundamental principles of physics for this experiment would be specifically Newton's second law, the momentum principle, the velocity update formula, and the position update formula. So getting into the lab procedure, you're going to first find an object that can easily roll or stay in motion for a period of time. In this case, it's going to be an expo marker. You're going to then place that object next to a meter stick or any object that can measure distance. You're going to then push the object along the meter stick in order to initiate motion, record and input the video data into Tracker to create a data table with results of the position of the object and the time. We're going to then use the data recorded to predict the future position of this object if the initial force or push applied was a constant force in GlowScript. And then we're going to compare those results. So for the observed data, the data recorded on Tracker shows that as time increases, so does the progression of the object in the x direction. This can be seen in the first graph to the left. And then for this section of the experiment, the velocity does change since both friction and normal force are acting on the expo marker, as well as some human errors, which is why in this case, the velocity graph on the right shows fluctuations, even though it is decreasing. And then this data will be used to determine a constant velocity in GlowScript with a net force of 0. So to transfer our information from Tracker to GlowScript, we're going to be using the velocity update formula and the position update formula. And we're going to use the initial conditions that you can see on the right here. And we're going to input that into our code, which you can see on the bottom right. So to find the new velocity, we're going to use the velocity update formula. And we're going to do the velocity plus F net divided by the mass of the object times delta t. And then for the position, we're going to do the initial position plus the velocity times delta t. And since this is going to be a constant velocity, F net is just going to be 0 vector all the way. So for the predicted data, it was very similar to the observed data. The main difference is, as we mentioned, the constant velocity, which you can see in the graph on the right, that it is just a straight line across the time and the velocity measured. And the predicted position and the time graph is also very similar to the observed, but it follows the trend line due to the constant velocity. So as I previously mentioned, they do follow the same trend line with some minor differences. On average, both sets of the data head towards the same position during the same amount of allocated time. Differences in data points can be due to forces acting on the object in each instance. For instance, in the first one, we were pushing the object, and then in the second one, it's going to be a constant velocity. It can also be due to human error or error in orienting the initial axis of motion. So to answer the what if and what does it mean question, what if when you analyze your video data and Tracker, you made a choice of the orientation of the axis? So for this case, we did need to change the orientation of the axis just due to the movement of the expo marker, and this affected the signs of the position. Some of the initial positions were in the negative direction, which affected our results when calculating velocity. And is it possible for you to say how many pushes and pulls, for example, how many forces are being added together to give 0 net force in the case that you observed? I would say that in theory it is possible because we know that, for example, friction, normal force, and pushing force are being applied to the object, but we wouldn't be able to find it to the exact degree since we do not know the exact measurement of these forces. That is all, and thank you very much.